Okay, so we're going to talk right now about relative motion, and it's something that's very simple but very tricky at the same time because it's very difficult to visualize. So the best way I could think of is, let's say you're driving on the freeway. If you're going along at like 70 miles per hour and the person next to you is going along at 50 miles per hour, then these measurements of your velocity are relative to the earth. Okay, so you're driving past like the tree at a rate of 70 miles per hour. That's how fast you're going to go past that tree. But your velocity relative to the other car is basically how fast you're passing that other car. So if the other car is going 50 miles per hour and you're going 70, then you're going away from it. You're increasing the distance between you and the car at a rate of 20 miles per hour. Okay? And so this is the idea of relative motion. And I have this formula on the screen. I don't like giving this formula. I don't really like using it. I think it's easier just to kind of think it through. But I'm going to give you this just so that you can use it if you'd like. Okay? So to go ahead and get started, I'm just going to kind of explain how this formula works. Okay? And then we'll go ahead and start looking at some examples. So the velocity of an object relative to the earth is equal to the velocity of the frame of reference plus the velocity relative to the frame of reference. So this just seems like a bunch of gibberish, so let's give it a try. Okay? So the example we're going to use is this. Okay? We're going to do a couple examples, but the first one is this. Okay, so we have a moving sidewalk, and in it we have a person. This moving sidewalk is actually stationary. Okay, so we have this person here and this person here, the blue person and the red person. They're both moving the same velocity. Okay, 5 meters per second. Actually, let's restart it. Let's say that person 2 is moving 6 meters per second. Okay, so you can see them kind of gaining on them a little bit. They're going a little bit faster, and they're separating away from them here. Okay, so the question is, what is their relative velocity? Okay, well, the way that we do this, coming back to here, we're going to say, okay, we're going to say for person B, the blue person, their velocity was 6 meters per second. Okay, and the red person, their velocity was 5 meters per second. And what I want to know is how fast person R is moving relative to person B. Okay, so how fast is R relative to person B? So here's how we would do this. So the frame of reference, the place that we're tracking it from, is person B. So we had this person here going a little bit faster, and we had this person here going a little bit slower. We want to know how fast this one person is going relative to this person. Okay, so what we'd say is this person is the frame of reference. So frame of reference here, the velocity would be 5 meters per second. That's the velocity of the frame of reference relative to the earth. Okay, now we're going to look at, person blue is 6. Okay, so that would be 6 meters per second. Okay, now person R was traveling 5 meters per second relative to the earth, and the velocity relative to the frame of reference is what we're going to solve. So we subtract 6 over, and we find that they're going negative 1 meters per second. So that means that the blue person is moving away, or to the blue person, it looks like they're walking away from them at a rate of 1 meter per second, or it looks like they're falling behind them at a rate of 1 meter per second. Okay, so we're going to do this again now. This time, though, we're going to give the sidewalk velocity. Okay, so we're going to add some velocity here. Okay, let's say the sidewalk is moving 3 meters per second. Okay, and so now you see the person going faster here because they're on that moving sidewalk. Okay, so when we figure this out now, we can say, okay, the velocity of the frame of reference, still 6 meters per second. Okay, but now the velocity relative to the Earth would be the 5 meters per second that they're walking, plus the velocity of the sidewalk, which is now 3. Okay, so now when we solve for this v here, we're going to get 8 plus 6, or 8 equals 6 plus v, or v is equal to 2 meters per second. So this blue person sees the red person passing them. Oh, we got to restart it. This blue person sees the red person sees the blue person passing them at a rate of 2 meters per second. And I'm just realizing now that I said all the colors backward the whole time, so I apologize for that confusion. Not like this isn't already confusing enough. Okay? But really, all we care about is the fact that this person is going 2 meters per second faster than that person. Okay? Alright, so the next thing we're going to look at is another kind of problem. Okay, a similar one. So we're riding in a car, and you see a car go speeding past you. Okay. A sign on the side of the road clocks the car at 95 miles per hour. So I don't know if you've seen those signs like in construction area that have the speed limit, say how fast someone's going. And then you're driving 60 miles per hour. And so it says, what is the speed of the car relative to you? So if you're the frame of reference, how fast is that car relative to you? How fast is it coming towards you, going away from you, and in which direction for positive or negative? By writing out the equation. So we'll say that velocity of car A relative to the Earth, this would be the car going past, is equal to the velocity of car B relative to the Earth plus the velocity of A relative to B. Okay? And so we're going to call this car right here car A, and U car B. So we can say, okay, car A is going to be equal to, they have a velocity relative to the Earth of 95 miles per hour. Okay, car B has a velocity relative to the Earth of 60 miles per hour. And so the velocity of A relative to B, we subtract that over and get 35 miles per hour. So they're going away from you at a rate of 35 miles per hour. So if you were going those speeds and you kept them up for an hour, after 1 hour they would be 35 miles ahead of you. Okay? That's basically how it goes. And then the next question here is, what is the speed of the car relative to you if the car is traveling in the opposite direction? Okay? So that's going to change one of these values. I want you to try to figure this one out. The speed of the car relative to you if the car is traveling in the opposite direction, that would make this be a negative 95. So that when we subtract 60 over, negative 95 minus 60, okay, is going to be negative 155 miles per hour. Okay? And so if they're coming towards you at 95 miles per hour and you're going towards them at 60, the relative velocity between you is 155, which means that after an hour you'll be 155 miles away from that car. Okay? The last thing I want to do is, if you're going 60, so car B is going 60, so this would be V of B relative to the Earth, and let's say you see the car going past you at a rate of 20 miles per hour. So what we're saying here is that the car is going away from you 20 miles per hour. Okay? You see it like passing you, going that much faster than you. So what would be the velocity of car A? You could plug it in here. This would be 20. This would be 60. So the velocity of car A would be equal to ED.